So this is the data abstractions concept. So we have three levels of data abstractions: physical level, logical level, and then view level. So physical level is nothing but it is an internal level. It shows how data can be stored. Example is data stored in disk using indexing. For the logical level, it's also called the conceptual level. It is a middle level. So what data is stored, like a table, schema, and relations. Example is student. In the student, so what are all the attributes are there? Roll number, name, department, marks. In the view level, it's external level. So what user sees or required data only. So faculty sees only name and. So it is a three types of levels we have discussed. So one more example is user. So what they can see: view level, student, roll number, name, department. Faculty, we can see only roll number, name, marks. Admin, we can see all the details. But user sees only the balance, how data is stored in database, withdraw amount, receipt detail. So this is the example for abstraction. So in data abstractions, data independence is also there. It is the ability of DBMS to change the database schema at one level without affecting the schema for the next higher level. Simple meaning is changes in database should not affect user programs. The example is physical data independence is changes in physical storage should not affect logical schema. So logical in data independence is nothing but changes in logical schema, but should not affect the view programs. But it is no changes are required at in logical level and view level. The example is adding index, changing the file organization. But in view level, adding a new column to students table without affecting the old. So this is the system architecture for our database management system. See, we have four users are there: Navy user, application programmer, sophisticated user, database administrator. So in this one, Navy user is nothing but it is a user actually who uses the database through the application or interfaces, but does not know how the internal working of DBMS or SQL queries. So his meaning is who use the database through an application interface but does not know the internal working of DBMS or SQL. So here they are giving Navy user means it is a normal user accessing the database using forms, GUI, menus, buttons. So how they use DBMS means you can use the interface, graphical user interface. Simple example: student checks marks in college portal. Application programmer is nothing but it is actually developer. We are writing the programs, so create student login applications. Sophisticated is nothing but it is advanced user. So we are using the query tools in SQL. So already table is there, we can update, delete or any information. So staff runs SQL to generate the report. So database administrator is nothing but it is admin actually. It controls the database. So you can give the access, write, backup or security. So we have different components are there: component, compiler and linker, DML queries, DDL interpreter, DML compiler and organizer, query evaluation engine. So compiler and linker is nothing but convert application program into executable code. So Java or C program connected with DB. So DML query is nothing but select, insert, update or delete queries. So select start from to student. Insert means insert into table name values of you can insert all the values. Update is nothing but you can update the existing values. So delete is nothing but you can also delete the previous informations or new record information. So interpreter is nothing but create or changes database structure. So create table, table name. You can create a new database or existing. You can change the existing database also. DML compiler and organizer is nothing but check and prepare query execution plan. So we can optimize the queries to run and faster. For evaluation engine actually runs the query and get the results. So fetches the marks from the database already we have created in the student table or any. So next we have a buffer manager, file manager, authorization and integrity manager, and transaction manager. In the buffer manager, the move data between RAM and disk. The example is load student record into memory. The file manager organizes the files on disk. It can also store the student table as a file. For authorization or integrity manager, you can security and constraints checks also used. Only staff can edit and then modify the marks. But in the transaction manager, we can ensure it is a safe update. You can check whether the update is correct or not. It's like they are giving the security option. So fee payment update, it's fully saved or cancelled. So it is one of the important options we have used in database system architectures. For next one, we can data index, indices, data in dictionary, and then statistical data is also. So we have used it actual table record, speed of searching, and then metadata used for query optimization. The example is student details. You can also, we can see the row wise or column wise or anything. We can easily we can view the data, the index and roll number, or fast search, and then table names, and then column types also. For number of rows in student table, how many rows are there, so everything can be displayed in database architecture. So finally, already we have discussed Navy user, application programmer, sophisticated user, and database administrators. So Navy user, through the application interface, we also get created, and then use the systems. We can check the marks. If the marks is greater than 80 or below 80, just we can see view the informations. So that is very very important. So next, application programmer. So in this application programmer, through applications program, you can also develop the software to access the DP. And the next is sophisticated users. So through the query tools or SQL, we can easily access the run the queries and report. For database administrators, we can use the managed security, backup, and the users. So this is the best examples for your database administrators concept. So overall, different types of users we have used. So next, query processor. So already we have discussed it, interrupt the request via an application program. So this is the processing, how query can be evaluated. It also execute the user request which is received from the DML compiler. So the query processor contains the following concepts. DML compiler, it process the DML statement into the low level, and then DDL interpreter, it process the DDL statements into a set of tables. For embedded DML pre-compiler, it process the DML statements embedded in the applications program. For the storage manager, it is interface between the information stored in the database and the request. It also known as the database control system. It maintains the consistency and integrity. So the main responsibility is managing the data manipulation, addition, deletion, and then for storage manager, these are all the components we have used: authorization manager, integrity manager, transaction manager, file manager, buffer manager. Authorization, it's like we are giving the security. Integrity is nothing but you can combining to check the integrity constraint when the database modified or not. Transaction is nothing but it has a different, it just they are giving the scheduled information. It's like performing the operations in a scheduled way that they receive the transactions that ensure that the database remains in the consistent state. So file manager, it allocate the space. Buffer manager responsible for cache memory and the transfer of data between the secondary memory. For disk storage, it is used to store all the information. It contains the following options. So the options are data files, data dictionary, index, and then statistical data. For data files, store the data. For data dictionary, it contains the information about the structure of any database object. It is the repository of information that governs the metadata. So index is nothing but it provides the faster retrieval of data item. So for statistical data, it can contain the logical schemas. So we have different models are there: hierarchical, network, entity relationship, relational, and then object oriented. For evolution of data models, we have first one is hierarchical model. The first and foremost model of DBMS. This model organizes the data in the hierarchical tree structure. This model is easy to understand with the real-time example site map of the website. For example, the following is the representation of relationship present on online clothes mapping. Cloth, we have men or women. So men, we have pant and shirt and vesty and shirt. Woman, we have sari and salwar. The features we have one to many parent-child relationship, deletion of problem pointers. We have used features. They are sort of features. The advantages are simple and fast traversals. Changes in parent node automatically reflected. Only the disadvantage, it is a complexity. Parent node deleted automatically, child node will be. For network model is an extension of hierarchical model. So this model was recommended the best before relational model. Same like hierarchy model, the only difference between these two models or record can have more than one parent. For example, consider the following diagram. A student entity has more than one parent. So college, department, library, student. So department, library have two entities are there, and then more than one parent. So this is a network model. The features of network models are manage or merge more relationship, more paths, and then circular linked list. Advantages of so linked list, already you know that the last pointing to the network in the list. And then advantages of network model is data access is faster because of parent child relationship. The changes in parent reflect in the child. The disadvantages more complex because of more and more relation. So ER model, this is the model high level data model, represent the real world problem as pictorial representation. Easy to understand by the developer about the specification. It is like a visualization tool to the represent specific database. So it contains the three components, entities, attributes, and so this is the evolution data models for entity related. It's an important model actually. In the DBMS, we are talking about only that ER entity relationship model. So other than models, we are not using, but important model is ER model and the relational model also. So in this ER model, yes, faculty works for department. Faculty have faculty ID, name, phone number, date of birth, salary. So in the department ID, department locations. So in the above example, the two entities, faculty and department, the attributes faculty entities are ID, name, phone number, date of birth. The attribute entities are department ID, name, and then location. So for the department. The features are graphical representation, visualization, good database, everything. Here advantages are better communication, easy to convert. Disadvantages are no industry. So this is the simple sample questions we are giving in the based on the topics.